Okay, hello class. YouTube again cut off my feed because it was some sort of copyright thing, which I don't know what I'm doing wrong. So if YouTube could hit me up in the comments or text me or something and let me know what's going on, why this is happening, I would love to know. I am unaware. So I'm going to pick up where we left off. So for chemistry block, hello, I wanted to go over some of these word problems with us. So how we solve for these equations, just because it's something that you guys are going to be doing for mini QPA 1. So nobody requested this. I just think it's something that we could always use more practice for, and hopefully it's helpful. You guys can rewatch this video. So the problem that we're working on is problem 3 from about 2 weeks ago that we worked on in class. So I'll read it again just so we have it. So if an engine's air fuel initially has a volume of 0.725 liters and a pressure of 1 atm, and then its volume decreases to 0.075 liters, what is its final pressure? Okay, and I'll post this into the description below so you guys have it in word form as you're reading, if you're watching this back. So first thing that I want us to do, I want us to get in the habit of setting it up like this. So what we know, so what is the problem telling us? What information is it giving us? What we want to know, so what is the problem asking us to solve for? And then the equation that we're going to use to solve for whatever it's asking us to solve for. So in this problem, what we know, it tells us it initially has a volume of 0.0725. So we know the initial volume. Remember, that's indicated by V with a little subscript I. Okay, and a pressure of 1 atm. So it also tells us the pressure initial. So that's again indicated by PI. And then its volume decreases to 0.075 liters. So it's telling us its final volume because it's decreasing. So it's undergoing a change. So that's the little subscript F. And what do we want to know? So it wants us, it says, what is its final pressure? So it wants us to solve for PF, P final. So P little subscript F. Okay. So now I know that it gives us initial volume, initial pressure, final volume, and it wants us to solve for final pressure. So what is an equation that we can use to solve for this? I think, I'm a chemistry student, I think back to the 3 gas laws that we talked about. So I have Boyle's law, we have Charles' law, and we have Gay-Lussac's law. So which one has these 4 variables in it? And I remember, I look back at my notes, I just remember off the top of my head, whatever. So I know that it's Boyle's law, which tells us that V initial multiplied by P initial is equal to V final multiplied by P final. So like that. So initial volume multiplied by initial pressure is equal to the final volume multiplied by the final pressure, and this is known as Boyle's law. So now what we got to do is we are solving for final pressure. So we want to get this final pressure alone. So I'll circle that. That's the one that we want to get by itself. So in order to do that, we have to divide both sides by this final volume. So there that is for you guys. So we divide, and that gives us P final equals V initial, P initial over P final. So that is our equation to solve for this final pressure. Welcome to those of you just joining us. I am going over a problem that was a problem similar to what you'd be working on for mini QPA 1. just so we have that more practice with it. So please feel free to identify yourself so I know who you are. I don't know who you are until you identify yourself, unfortunately. I'd love to give you a shout out, say hello, and let me know if you have any questions. So then we just, at this point, since we know what our equation that we're going to be using is, we just plug in the numbers that it gives us in the problem and solve. So we can write these down. So it gives us V1, P1, and V2. So I'll write these down for us real quick. So V initial is 0.725 liters. Make sure we're always using units, because in science, if you just say 5 what? 5 elephants, 5 tons, 5 liters, 5 eons. Like, what are you talking about? I need to know the units, so the context of what you're talking about. The pressure is very simple. It's 1 atm here. And then our final volume is 0.075 liters. So there we have it. All of our problems. Hi, Di. How are you? I'm doing a chemistry problem right now, so I don't think you're in chemistry. You're not. So welcome. I'm glad you're here. So I'm just going to go over this for my chemistry students. You're welcome to stay. I'm glad to hear from you. Hope you're doing well. So then we plug in the equation, or we plug in these numbers. And again, 0.075. So this is the number that I come up with. And sorry, this is supposed to say PF. So that's our final pressure. And then 9.67, if I did my math correctly, please someone double check me on that if I didn't. And the reason why we were able to do this is because all of our values are in the correct units. So we want to make sure that our volume is in liters and that our pressure is in ATM in order for this to work out. So then we get our answer in ATM. So 9.67 ATM, and that should make sense. So a way to double check yourself is what you expect to happen given our law that we have. So as pressure goes up, we expect volume to go down and vice versa. So in this problem, we see volumes going down. So we would expect pressure to go up. And our pressure goes from 1 ATM to 9.67 ATM, which is a big jump. And that's what we would expect because it goes down by quite a bit as well. So our volume went down 0.725 to 0.075. Okay, welcome. We were just going over a problem for our chemistry class, so you guys can play that back, pause it as needed. We'll go over another one, but now we have new people joining us, so I want to open it up to you if you guys have any questions or anything. So welcome if you have any questions or comments. Hi, Mr. Souza. Thanks for the support. You too, ditto. Thank you for joining our online chat. We just did our chemistry problem, so I'll post this here. So if you guys need to pause it to go over it, I know none of my chemistry students are currently in the chat, so hopefully they'll watch it later so they can go over that. I'll do another problem for them. Please let me know if you have any questions. Who's still with us? Both of us.
I can't swap.
Do you have any questions, Di? How are you doing? I miss seeing you. I'm glad that you're here. And you too, Mr. Souza. I miss seeing you as well. My house is very noisy this morning. Hopefully you guys can't hear it too well, but there's music playing.
That's gotta go. Oh, boy. Oh, boy, good investigating you guys did.
Okay, so we'll move on to a second problem. It's a little more tricky, hopefully, if I can find my Sharpie. I apparently have misplaced it. There, I found it.
I'll try to
Crisis
keep that
averted. So I'll pull up a second problem for us that's dealing with either Gay-Lussac's law or Charles' law.
But, yeah, well, yeah, you've been opposed to me, that's the worst part. But, yeah, no shit. Boy, that's a bugger, huh?
Okay, so I found one. So if a 32-liter balloon is cooled from a temperature of 298 Kelvin to 273 Kelvin, what is its final volume? So let me just quickly write out what we know. Take a minute if you guys know what we know. Also, I'm going to post it in there so you guys can use this as practice.
You just one wire?
So again, I have it set up as what we know, what we want to know. I'm going to hold it so we have that. So what we know, what we want to know, and then our equation. So what we know is it tells us our initial volume, so volume 1. It's also telling us our initial temperature, and then it tells us our final temperature. So you can write this as T2, T1. I wrote it as T2 in this equation, just so we're varying what we're doing. So we know our initial volume, our initial temperature, and our final temperature. So that means we want to find our final volume. So we're looking for V2 right here. And then I think back as a good chemistry student, what is a law that deals with volume and temperature? I know that this is Charles' law. Which tells us that V1 over T1 is equal to V2 over T2. So that is our equation that we're going to be using. V1 over T1 is equal to V2 over T2. So we want to get what? We know that we want to solve for V2, so we want to get V2 alone. So in order to do that, we just multiply both sides by the T2. So our new equation to solve for V2 is going to be V2 equals to V1 multiplied by T2 is equal to, or I'm sorry, over T1. So like that, I apologize for all the mistakes I'm making. I'm a sloppy writer, so there's mistakes. So that's V1 multiplied by T2 is over T1 is equal to volume 2. So then again, we just plug in the numbers that we have. So we know that V1 is equal to, what did it tell us? V1 is equal to 32 liter. T1 is equal to 298 Kelvin. Again, make sure we're using our units. And then T2 is equal to 273 Kelvin. So we have what all of our values are right there. So we have all of that. And then we solve. So we plug in those numbers into our equation. So our V2 equals equation to solve. So it's going to be 32 multiplied by 273 divided by 298, which gives us a volume of 29.3 32 liters. So all of our units of our initial values are in liters for volume and then Kelvin for temperature. And we see that they're already conveniently in those specific values, those specific units. So we're all set there. And then we get our problem. And then just to double check to make sure that this number makes sense, we look at the relationship between volume and temperature given by our Charles law. So we see that as volume changes, if it goes up or down, temperature is going to do the same. So as volume goes up, temperature is going to go up. And same thing. So if temperature goes up, volume will go up. So in this problem, we go from 298 Kelvin to 273 Kelvin. So we see that temperature is going down. So we would expect volume to do what? To also go down, right? So volume goes from 32 to 29. And 29 is less than 32, so our volume is also going down, so we're all set there. So I'll leave this here. My battery is running low, but just so you guys, if you need to pause it to look at the whole shebang. So hopefully that was helpful. Please let me know if it wasn't. Hopefully some of my chemistry students get on to look at it at some point. So please let me know if that was helpful. Please let me know if we have any more questions. So I'm going to stay on for a little while. I'm going to go grab my charger so my computer doesn't die on me. That would just be another reason for this stream to not happen. So I'll be right back. Woo! Crisis averted. My charging situation has been figured out. Okay, let me see if I have any. So let me see if nobody's on. So we just solved some of our problems that were on Mini QPA 1 that are in the stream. That document is posted in the stream of our Google Classroom. So I'm going to stay on here for if you guys have any questions.
Was he born April?
April 1st. What they probably figured, it's an estimate. What is he gonna be, 4? He's 16, right?
What? So I have like intense shower. Just on. No. Won't be just one?
I didn't add.
Feed the cat. What happened to the cat? Sleep shallow? Oh, yeah. I'm not expecting you, right? Did you other friend enjoy food? When I'm around.
So you guys have had some good questions so far today. I really appreciate you guys showing up with your questions. So keep it up. So I'm going to stay on for my D block. So D block will be starting in about a minute. So hopefully we get some D block folks in here. And this video doesn't get removed because I would be devastated. Hello to those of you just joining us. If you're in my D block or any of my blocks, welcome. I'm glad to see you. Hopefully you're doing well. Please give me a shout out in the chat so I know who you are. This is stupid. Make sure you guys are subscribing to my channel. I put out new videos every Monday, Wednesday, Thursday at 10 a.m. for both chemistry and biology. And then we do these live sessions from about 9:30 until 11:30 on Tuesday, Thursday. I have 19 subscribers. Hello to you just joining me, please write in the chat so I know who you are. And if you have any questions, fire away. Let me know what you're thinking. Oh, and you just left. Bummer. Hi, Darius. How are you? Please let me know if you have any questions or comments. In the earlier part of this video, I solved a couple problems for you guys that were on Chemistry Mini QPA 1. So once this is posted, please take a look back at that so you guys have more practice doing that. So let me know if you have any questions, Darius. It's good to hear from you. Hope you're doing well. Oh, so Darius, good question. So for mini QPA 2, you for the first part, you are watching those videos that I posted onto Google Classroom. I can go on Google Classroom real quick to give you a reference for when I posted those. So there are 4 videos for the labs that you are watching and then answering questions for. So each lab corresponds with a different video. So lab station 1 through 4, and they should all be labeled on the Google Classroom stream. I posted the lab videos on March 18th. And so lab station 1 through 4 are all labeled. And we also, I think you were there for part of the day in class. So with the syringe and the marshmallow, the candle with the water, how it pulled the water up, and then the balloon on the hot plate, and then the can on the hot plate. So watch all those videos and answer the questions following on the mini QPA. So the mini QPA document. And then you're deciding if the which laws are being represented. Hi, Miss Petrie. And you're deciding which laws are being represented. So we have Charles' Law, we have Boyle's Law, and we have Gay-Lussac's Law, and those are all given to you at the top of the mini QPA page on page 1. So you are deciding which law is being represented by which videos. And then there's some more, there's 2 analysis questions. So instead of watching a video, you're given a scenario, and then you're telling me which law, again, is being represented. So what variables we're seeing. And then finally, you have 2 practice problems. And earlier in this video, I did some practice problems that are similar to what we did under mini QPA. So you're given 3 variables and then asked to solve for a 4th one, and you guys need to do that. So if that wasn't clear, please let me know. I see that you're talking with Miss Petrie, so you might feel a little distracted. So maybe play back the video, rewind it a little bit. Okay, that seems easy. So hopefully it's not super easy, but it's also not too complicated. So let me know if you have any questions or trouble with that. And then once you're done with that, you can just email it to me. How you doing, Miss Petrie? Oh my God. Try to do it on your own. If you have any questions, I would rather you ask me because I want to see what your what you know. So try to do it by yourself. Yeah, I miss you guys. Miss seeing you. We're all navigating it together, though. Okay, Darius. My cat's over here playing. Let me show you. Oh, here he is. There he is. Name is Izzy. He's a pain in the butt. Say hi to the people, Iz. Say hi. Say hi to the people, to the masses. He's over me. Okay, yes, please email me if you have any questions. Or you can comment on Google Classroom. Please subscribe so you get updates and alerts for when new videos are posted. So I posted a new video yesterday. And you also be safe and always wash your hands. Good advice from Darius. I'm getting kind of hungry. I'm gonna go eat some peanut butter chocolate chip toast after this. Bye, Miss Petrie. That was you saying bye. I don't know if you're just saying bye to Darius. Hmm. So I don't know if it's just me anymore in this chat or if I have any visitors. So please ask me any questions if you have any questions or comments. I'm here to answer them. Do, 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 do. Oh God. I was just gonna drink out of my copyrighted mug and I don't want to lose this entire video, so.
Going to the bed. The Bethany? What do you gotta do in the bathtub? You on the,
Yeah, I'm on the phone. Thanks.
drink it before it gets cold.
Just got some coffee delivered. It was great.
That's what it attacks. What do you mean? What did Jesus say? Huh? Marissa? Huh? Oh, thanks, Doc. No. For doctor. You were a Fabrizio.
Okay, if no one else is coming to this, I'm signing off. So this has been our live session. Again, make sure you subscribe so you get alerts as to when these videos are being posted. And yeah, make sure you're staying safe. Bye.